Electromagnetic radiation is familiar to each of us in that we use electromagnetic waves to listen to the radio, watch TV, and even microwave our food. Electromagnetic waves are produced by the motion of electrically charged particles. These waves are also called electromagnetic radiation because they radiate from the electrically charged particles. Electromagnetic radiation also acts like a stream of particles, called photons, that have no mass. The photons with the highest energy correspond to the shortest wavelengths. Also, at shorter wavelengths, light tends to behave more like a particle, whereas the longer the wavelength, the more light behaves like a wave. Electromagnetic waves can be seen on the electromagnetic spectrum according to their energy, which is measured in electron volts, wavelength, which is measured in meters, or frequency, which is measured in hertz. The visible portion of the electromagnetic spectrum occupies an intermediate position between infrared and ultraviolet on the spectrum, and exhibits a unique mix of ray, wave, and quantum particle properties.
This little light of mine, I'm gonna let it shine. This little light of mine, I'm gonna let it shine.
Transmission occurs if the frequency or energy of the incoming light wave is much higher or much lower than the frequency needed to make the electrons in the material vibrate. Then the electrons will not capture the energy of the light and the wave will pass through the material unchanged. As a result, the material will be transparent to that frequency of light. In a transparent medium, light can travel through from one side to the other unobstructed. This means that the atoms or molecules within the material do not absorb or scatter the light. Because the light passes through without hindrance, it can reach our eyes to show a clear image of what is on the other side. Most materials are transparent to some frequencies, but not to others. For example, high-frequency light, such as gamma rays and X-rays, will pass through ordinary glass, but lower-frequency ultraviolet and infrared light will not.
Try to leave a light on when I'm gone. Something I rely on to get home. What I can feel at night and make it right. The fire to keep me warm.
Translucent mediums do allow light to pass through them, but they absorb, scatter, and diffuse the light, so that the light no longer follows a known path. Incoming light waves get reflected at all sorts of angles because the surface is uneven. So, the light emerges from the material in all directions, having traveled varying path lengths, and images are not transmitted. When light passes through a translucent object, the visual perception is that the object is glowing.
Try to leave a light on when I'm gone. Even in the daylight, shine on. And when it's late at night, you can look inside. You won't feel so.
With an opaque material, absorption occurs, and with absorption, the frequency of the incoming light wave is at or near the vibration frequency of the electrons in the material. The electrons take in the energy of the light wave and start to vibrate. Absorption can then occur when the electrons are held tightly, and they pass the vibrations along to the nuclei of the atoms. This makes the atoms speed up, collide with other atoms in the material, and then give up as the heat the energy they acquired from the vibrations. The absorption of light makes an object dark or opaque to the frequency of the incoming wave. For example, wood is opaque to visible light, and the color black is opaque. Some materials are opaque to some frequencies of light, but transparent to others. For example, glass is opaque to ultraviolet light, but transparent to visible light.
Yeah. Sierra.
particles of light are called photons. They travel in straight lines until they strike a surface and are extremely small because they don't scatter when beams of light intersect. Light particles, or photons, travel at very high speeds and are created by luminous objects. They are reflected or absorbed by non-luminous objects. A second model of light is the wave model. The colors of the familiar rainbow of visible light correspond to differing wavelengths of the light. Since light is both a particle and a wave, there is an interference effect. The final model of light is the ray model. This is the simplest model of light because it is useful when light is interacting with material objects that are much larger than a wavelength of light. Cited by VIAS. A real image is an image where emergent rays converge to a point. Real images can be viewed by the reflection from a screen placed at an image's location. The light rays forming the image actually pass through the physical location of the image. Cited by SFASU. A real image is an image that can be found sharply detailed on a screen. An example of a real image is an image a camera lens casts on film. A virtual image occurs when emergent rays diverge from a common point. A virtual image can only be seen by looking through a lens back toward the source of light. In a telescope, the image you see when you look through it is virtual. Virtual images cannot be formed on a screen. The light rays forming the image only appear to pass through the physical location of the image, according to SFASU. Virtual images form on the objective side of a lens. Another example of a virtual image would be an image you see of yourself when you look in a mirror.